Hello everyone, a very warm welcome to this video. In this video, we are going to talk about how to go about doing the hands-on exercises, or in fact, doing hands-on exercises. In the previous videos, we've seen what is the intention of this section. We've also seen how to set up labs for the first time, and now we are going to do some hands-on exercises. As discussed previously, we will have two virtual machines and we'll be typing exactly same commands on both of them, so that eventually we have two machines running Hadoop, and later on we'll create a multi-node setup out of them. So let's get started. Now for simplicity, what we are going to do is we will take both the machines and we'll log in using a putty kind of a tool so that it's easy for us to type commands. So the first thing we are going to do is we are going to look at the IP addresses of both the machines. Now it's possible that the SSH service is not running on your machine, so make sure you check the status of it by typing your password is training. So SSHD should be running. If it's not running, make sure you start the service. So on both the machines, SSHD is running. So let's quickly take the IP address of both the machines and let's run them. So let's open terminal and let's log into each and every machine. SSH 172.16.146.241. Your password is training. So we are logged into the first machine. And we are logged into the second machine. So as of now, we are logged into both the machines. And now let's run the instructions. So here we are, and these are the two machines that we have. So first, we've installed VMware Player. We've logged into the machine with username and password, and we have all this ecosystem projects ready for us. We just need to run the instructions now. Now, the first command tells you how to install Hadoop. Now, this involves downloading Hadoop from the repository, which will take a lot of time. And for that, I have already run this command, and the bracket already has this for you. Already done for you. Please don't run this command. So let's assume Hadoop is right now downloaded and installed. We just need to set it up. In the next step, we are going to see if Hadoop is actually installed or not. So to do that, the command is rpmql hadoop-conf sudo. If you see set of configuration files, that means Hadoop is actually installed on this particular machine. Had it not been installed, it would have given an error, package Hadoop not installed. Just to give you an example, if I was to do rpmql php, the answer is package php not installed. So had Hadoop not been installed on this machine, we would have got this error that package Hadoop not installed. So as of now, Hadoop is installed and the command shows us all the configuration files that are there. In the next step, we are going to format the name node. Let's understand what does format mean. Now, if you really see in a cluster, there is master and there is slave. Now the master has to, or the slaves have to talk to the master based on an ID called as namespace ID. So when you just install Hadoop, the namespace ID is not, it's not initialized. So format is the command that is used to initialize the name node and give it that namespace ID so that data nodes can talk to the name node. Just to reiterate, currently you have a single VM where there is name node and there is data node or data nodes, and the data nodes will talk to the name node using namespace ID. And this namespace ID could be only given after you format the name node, So let's format the name node. We'll have to do it on both the machines because we are parallelly doing all the steps on both the machines, and eventually we will connect them as master and slave. So in this case, the name node is formatted. Let's go to the next machine and format that. So as of now, both the machines are formatted. The next command that we need to do is we need to stop all the services or existing Hadoop services if they are already running on the VM. So let's do that. So this command takes all the services that starts with a word Hadoop in etc initd folder and shuts them down. So we see that data node is getting shut down, name node is getting shut down, name node was not running at all. History server, secondary name node, node manager, and resource manager. All of these will shut down right now. We can ignore this history server warning. We'll have to run exactly same command on the other machine. So we see that all the services are also getting down on machine number 2. Next, we are supposed to start only HDFS services. So when we talk of HDFS, we are talking of services like name node, data node, and secondary name node. So let's start them. So on both the machines, we see that HDFS services are getting started. Now there are two ways to verify if the services have started or not. Let's look at both the ways. First way is by running the JPS command. Now JPS command is a command that is used to verify if or what Java processes are running in our system right now. The command is cd user java latest bin jps. So what we are supposed to see is that name node should be up and running, data node should be up and running, and secondary name should be up and running. Rest are some other Java processes which we are not concerned right now. So now at least we are clear with the fact that this is how our HDFS has come up. Let's go to the next machine and verify that again. Here we see data node, name node, and secondary name node. That verifies that on both the machines HDFS is up and running. There is other way to see it, and that is through the browser. So let's open a VM. And what you see is that the name node is up and it has one slave node. Name node is up and it has one slave node. So this is the name node web UI, and this web UI shows if name node is up and not, and the live nodes will tell you if data node is up or not. So this is how, or this is where we verify our HDFS is up. Our next focus would be to bring up yarn services. Now to bring up yarn services, we will have to create some folders for yarn. One is temp folder. That's where all the temporary data is written by all ecosystem projects. Second is a log folder for logs in HDFS. And third is the history folder where all the archives or status of each job would be maintained. So let's create those directories. After we create those directories, we will start yarn services and verify if yarn has started or not. So let's do that. So we create this directory, and for staging directory, we should make MapReduce or MapReducer as the owner. So after we have MapRed as the owner, let's make sure that temp directory is completely accessible. Let's create a directory for logs. Use a -p option, and then let's give the ownership of that directory. So like this, we've set up all the directories. Now let's start the yarn services on this machine. Let's verify yarn services, and then we'll go to the next machine and exactly replicate the same process. So first we start the resource manager. Then we'll start the node manager. And then we'll start the job history server. Now once all the three services are started, let's verify that by running a JPS command. And what you see is that resource manager is up, node manager is up, and job history server is up. So this testifies that on first machine, Hadoop is 100% installed. So we first formatted the name node, we set up HDFS services, we set up yarn services, and at this moment, Hadoop is 100% up and running on machine number 1. Now let's replicate that on machine number 2. So we'll start by creating the directories. So staging should be owned by MapRed user. We should make temp directory writable. We create log directories for Hadoop yarn. So the permissions are given. Next, we will start the yarn services. So after resource manager, we'll start node manager and map reduce history server. Once all three are up on machine 2 also, Hadoop would be 100% up and running. It's time to start the history server. So let's run a JPS command to ensure that Hadoop 2.x is 100% set up. So you see resource manager, node manager, and job history server. All the three services are up on machine number 2 also. Other way to verify this would be going to the UI and doing localhost. So this tells your resource manager is 100% up and running, and the resource manager has one slave, that is node manager, and even that is up and running. So at this moment in both the machines, HDFS and yarn is 100% up and running. The next step is to create some input data and dump that data into HDFS and see if we can run one of our MapReduce programs. So once we are able to run our first MapReduce programs on both the machines, we would successfully have 100% installed Hadoop on both the machines. Let's get started. So the next step is to create home directory on HDFS. So we are logged in as Hadoop. We are logged in as training in this machine. That's why training would be our current user. And the owner for training should be user training. We will then create a directory input in user training folder, and we'll dump some data from etc Hadoop conf folder. So the input folder has all the data right now. So if you do Hadoop fs ls input, what you see is there are 4 XML files: code site, HDFS site, MapReduce site, and yarn site. Now that data is ingested, we are going to run a very simple MapReduce program that is created by the developers of Hadoop. We have not created it, the developers of Hadoop have created it. All we need to do is run this program to see if we are getting desired output. So we say Hadoop jar user lib Hadoop MapReduce examples.jar. In that, the main Java program is grep. This is not a Unix grep. This is the main Java class called grep. Our input data is in input folder. We expect output to be in output folder. We are trying to search for any string that starts with DFS followed by A to Z. Let's run this program. So you see that the program is running right now. So we'll have more details of how to see output of program and everything in the later sections. Right now our goal is to see that, okay, my Hadoop is 100% up and running. Can I run a simple program? Can I run a simple program? That's the agenda of this particular lab. So you see that the job is running with certain percentages. Alright, so looks like the program has successfully run. Let's verify that. We previously created a directory input and now we have got a new directory output. And within output, we see 2 files. One is success, that shows that the program was successful. So if you're writing a workflow, if you see a success file in a folder, that means the job was successful. If you see failure file, then the job was a failure. Here we see success and then we also see a part file. Let's see the contents of part file in output folder. What you get is there were some 10 strings that started with DFS. In those 4 files, there were around 10 strings that started with DFS, DFS safe mode, minimum data nodes, extension, replication, and so on and so forth. So this testifies that we have run our first MapReduce program successfully. So on one of our machine, Hadoop is 100% up and running with a sample program also. Now coming to the second machine, what we've so far done on second machine is we've made sure all the services are up and running. Let's quickly replicate the whole thing. So we create a training folder. We give permission of training folder to a user called training. Let's create an input folder. Let's dump those XML files. And let's run the program. And we are trying to search for any string that starts with. Submit the program and the program is running. So once we have this program successful on both the machines, we have installed Hadoop, HDFS is up, yarn is up, and we have successfully run our first MapReduce program. That was the agenda of this particular video, and here we see that the job is successfully running. The details about how this job is running and how to track it from the UI will be there in the next videos. So we see that the job was successful. Let's look at the output. And we get the same set of strings. So this brings us to the end of this video where both the machines have Hadoop 100% installed. And in the next video, we'll practice some HDFS commands: MapReduce, scoop, hive, pig, and flume. Thanks for watching this video.